7.5, using matrices. Our learning intention, how do I use matrices to solve real-life problems? And our success criteria, I can represent and solve matrices for real-life situations. Using matrices. Matrices are often a convenient way of representing real-life information, and matrix arithmetic can be used to do relevant calculations. The advantage of matrices when you use a CAS calculator is that they allow you to do a large number of calculations quickly. Yes, it is possible to do it all without your calculator, but it makes it so much easier if you use one. Example number 12, I'm on page 40 of your textbook if you're following along. Each week, the coach of the Little Diggers basketball team awards the Best and Fairest Player award to the player who scores the most game points. The results of their last game were Asma, Sarah, Lucy, Matt, Callie, Minley and Sophie are all players on the team, and they scored a combination of 3-pointers, 2-pointers and 1-pointers, as seen down there. So Asma scored no 3-pointers, she scored 5 2-pointers and no 1-pointers. So part A asks us, write a column matrix P to represent the 3 different scores possible. So when a player scores, they can either get a 3-pointer, a 2-pointer, or a 1-pointer. So these are the 3 options available when they're shooting. Not that they're really options, it's just whatever you get in. So we can either get a 3, a 2, or a 1 when we're shooting our goals. Now this question asked for a column matrix, so I've taken the information from up the top here from the row and put it into a column. It didn't change the data or the elements at all, it just changed the position of them, just because we're asking for a column matrix, not a row matrix. On to part B. Write a matrix G to represent the data from the table. So the data from the table, I'm going to jump back a page here. This is the data from the table. All this information. And really all I need to do is put square brackets around that and label it as G. At the moment I've got 7 rows and I've got 3 columns. And I need to keep that the same. So I need to keep this as a 7x3 matrix. I need to label it as matrix G. And then I just take the same information from the table, keep it in the same rows and the same columns, 250, 170, 022 and 180. I went a little bit large and a little bit crooked again. Let me neaten those 2 up. Done. Marginally better. So now I have a matrix G that represents the data from the table. I haven't amended any of the data. Haven't altered any of it, I've kept it as is. Part C, use matrix multiplication to find a score matrix named S. So we're going to call our new matrix S that represents the total scored by each of the players. Now to figure out the total score, we need to find the game, or how many goals, times the number of what each of the goals were worth, so the points. So at the moment we're going to have a 7x3 matrix times a 3x1 matrix, that's what P is, and we will end up with a 7x1 matrix, just looking at those 2 outside numbers there. And that will represent the personal total for each of the 7 players. So we've got 0, 5, 0, 1, 3, 2. I'm just going to jot this down again. 2, 5, 0 will be a little bit neater now. 2 and 1, 8, 0. Then I'm going to multiply that by 3, 2 and 1. I'm going to do the top one for you, but then I'm going to just summarise the rest of them because the answers are on page 41, also on my PowerPoints. So 3 times 0 plus 2 times 5 plus 0 times 1 equals 10. So I'm running out of room. So this first multiplication would have 10 at the top. If we ran through all of them, we'd end up with 10, 11, 14, 16, 17, 6 and 19. I've got a number 6 down here for Min Lee. No, she didn't score many points, but there's a fair chance she's a defender, not an attacker. So looking at this table, our biggest number here is number 19. Our smallest being number 6. All we need to then do is look at that row number in the original table to be able to find the corresponding point scorer. There we go. Part D asks, which player won the best and fairest award? So looking at that table again, 10, 11, 14, 16, 17, 6 and 19. I look for the largest point scorer, which is the last one there. And if I went back to my table, I would see Sophie. And Sophie had 1, 8 and 0, which was 1 times 3 is 3, 2 times 8 is 16. So they're my 3 pointers, my 2 pointers and my 1 pointer. And she totaled 19 points. Therefore, she won the award for the game. Now, a lot of the time, computers will actually be doing matrix multiplication behind the scenes. So we put the data into the computer and it calculates it for us. We don't actually have to do this, but it's good to see how we can apply this if we were to sit and physically do it ourselves. Part E, the opposition team scored a total of 87 points. Did the Little Diggers win the game? So how do we find what the Little Diggers scored in total? What we do, I'm going to go back to red so it's all consistent. S is found, or the, no, let's try that again. So the total is found by adding all elements in S. So all of our numbers from up here. So 10 plus 11 plus 14 plus 16 plus 17 plus 6 plus 19 gives me 93. Now looking at the numbers, the opposition team got 87 and the Little Diggers got 93. So therefore the Little Diggers won. All right, example 13. The manager of a local hardware store purchases metal fasteners for $3 each. Now, when we're looking at this, we try and pick our key information out because it's going to be pretty important for us a little bit later. And large metal fasteners for $5. So small for $3, large for $5. In the last 2 weeks, he has purchased the numbers of fasteners shown. So he's purchased small fasteners in week 1, 121 of them, and large 112. That's some pretty big purchases there. And in week 2, purchased 95 of the small ones and 85 of the large ones. Part A, find the 2 matrices that can be multiplied to give the total purchase cost of metal fasteners in each of the 2 weeks and their final product. So that means we need to start by converting this guy into a table, into a matrix. Put that down there. So week 1 would have 121 and 112. Now I'm not changing the position of any of my elements. I'm just transferring my data into a matrix. Then I'm going to multiply it by the 2 costs we've got. Now, having a look, small fasteners appear in the first column, large in the second. So I'm going to keep that the same when I put that into a column matrix. I'm going to put the small ones, the cost of the small ones first, and then the cost of the large ones second. Then if I was to multiply that through, whether you use a CAS or you use your hand, you would end up with $923 and $705. So in week 1, and week 2, I spent $923 and $705 respectively. So I spent about $1,600 in fasteners. Moving on to part B, the manager sells the goods at a 55% markup. He recorded his purchase costs over the last 2 weeks for metal fasteners and 3 other items in this table. So metal fasteners, we found that 923 and 705. We found that on the previous matrix. He also sold paint, timber and gardening tools. Now, part B1 asks us to represent these costs in a 4x2 cost matrix called C. So what we do is, again, we just take all this data, put brackets around it, and create a matrix. So 1060, 1555, 3029 and 1124, 923 and 705, 896 and 1230. Put a square bracket around it. This is my matrix, my cost matrix. So that's how much it's cost me for those 2 weeks. Part 2 asks or says the selling price is calculated by finding 155% of the cost price. Convert 155 to a decimal. Now, in order to find a decimal, so we go 155% is equal to 155 divided by 100, giving me a decimal of 1.55. So we're going to use this number when we're doing our calculations shortly. B, part 3, using scalar multiplication, represent the selling price of these goods in a 4x2 matrix S. Now, the selling price is equal to 1.55 times the cost price. So S is equal to 1.55C, which is equal to 1.55 by 1060, 1555, 3029, 1124, 923, 705, 896 and 1230. Then we multiply each element. So I would start by doing 155 by 1060, and I end up with 1643. Then I've done my calculations previously. 24, 10, 25. Yes, it's okay to have cents because we're trying to figure out how much it's cost us in total. You know what? I might move that entire matrix down because I've got plenty of room here. So we've got 1643, 24, 10, 25, 46, 94, 95, 1742 and 20 cents, 1430 and 65, 1092 and 75, 1388, 80 and 1906, 50. So the selling price is considerably higher. It's 155% times. All right, on to part C. Create a profit matrix. Assume that all of the goods purchased over these 2 weeks are sold. So, profit equals selling price minus cost price. My accounting kids know that. I've drilled it into them a few times. So, P is equal to S minus C, which is equal to, and we're writing these out again, 24, 10, 25. I'm just taking this S from the previous slide. And 1742, 20, 1430, 65, 1092.75, and the bottom one's 1388, 80, and 1906.50. I'm going to give you a hint and say, normally when I would figure this out myself, as in create problems and stuff, I keep things as nice whole numbers. Decimal points annoy me. Gets too messy. And then I use my C from the previous slide, or from 2 slides ago actually. So 1060, 1555, 3029, 1124, 923, 705, 896, and 1230. Now, remembering from matrix addition and subtraction, what you need to do is you subtract the same elements. So if we take the element in matrix S in position A11, I have to take the element in the same position in the other matrix. And I end up with 583, 855, 25, 1665, 95, oops, bit of a scribble, 618, 20, 507, 65, 387.75, 492.80, and 676.50. Sorry, my handwriting's getting really sloppy, but I'm trying to squeeze it all in. And that's my profit. Part 2 of part C says calculate the total profit to be made if all the goods sold or purchased over these 2 weeks are sold. So what we then do is we go and we find the total profit by adding all elements in P. So we do 583, I don't have enough room to write everything, plus 855.25 plus 1665.95 all the way in. And our total profit dollar figure is 5787.10. So all I did was I added all of these elements together to get my profit of $5,787.10. Moving on to example 14. Matrix B shows the number of sightings of rare birds made by members of a bird watching club. So these are our birds. We have the flitter, the bitwing, and the red twit. And these are our members: Harry, Esther, Ania, and Gordon. And then we have P and Q, which are summing matrices. As you can see, P is all ones in a row, and Q is all ones in one column. So part A, calculate the product A equals PB. What information is given by this matrix? So what we do is I'm going to change back to blue, it's nicer. A equals PB. Note that I'm putting my summing matrix at the beginning. Because the summing matrix goes at the beginning and it's a row, I have to add my columns. So 1, 1, 1, 1 multiplied by 13, 3, 4, 2, 5, 2, 1, 1, 3, and 5, 7, 10. So when we multiply by a row matrix, we add the columns. So adding them together, and I end up with 21, pop it directly underneath, 21, 16, and 19. Put my brackets around that. Now, what does A give us? A gives us the total of each type of bird sighted by the club on the weekend. So that 21 represents how many flitters were sighted, the 16 represents how many bitwings, and the 19 represents how many red twits. So what does the information in A13 give us? So let's jot down A again, 21, 16, and 19. And 1-3 means row 1, column 3. So we've only got one row, so we look at column 3, which is the 19. And that element indicates the total number of red twits. Total number of red twits sighted on the weekend. All right, so on to part B. Calculate the product C equals BQ. So we need to find C. And we need to multiply B times Q. Now B is our bird watching matrix again. 13, 3, 4, 2, 5, 2. Oops, 1, 1, 3, and 5, 7, 10. And we are multiplying that by 1, 1, 1, a column matrix. Now, because we're multiplying by a column matrix, remember that we've got to add our rows together. So we end up with 29, 5, and 22. What information is given by this matrix? So C, which is what we've just found, C gives us the total number of birds sighted by each bird watcher. So because we've added up the rows, remembering this top one here was Harry, then Esther, then Anelia, and then Gordon. So that very top row, that number 20, would be how many birds that Harry sighted across the weekend. Part 2, what information does the element C21 give? Now, we're after row 2, column 1. So find our second row, and we've only got one column anyway, so that's the number 9 there. And the element in C21 tells us that Esther sighted a total number of 9 birds on the weekend. All right, so that is it for 7.5. I'll meet you back for 7.6. Thanks.